So the session this morning is called An Introduction to Career and Research. So we're going to hear from two people, Dr. Jeronimo Bernard-Salas from ACRI-ST, so I'll let him talk about that in a second, and also someone from Dr. Marcell from Blue Sky Space. He's on his way from another session. So we'll get started with ACRI-ST. We'll have a little bit of a monologue from you, if that's okay, about your role and about ACRI. And then we'll roll into a bit more of a discussion, so you guys can ask some questions about maybe career-related things or any advice on when you're applying for jobs, these kind of things. So I'll let Jeronimo get started. You can use this to advance the slides.
Okay, thank you. Okay, so I was asked to ask a bit about the company where I'm working for now, so which is ACRI-ST. So ACRI-ST is actually an SME, so a small medium enterprise of the space sector. And we basically provide engineering services of any aspect of data from satellites. We work a lot, with space agency mostly, but also environmental agencies and also politicians. So basically we have ACRI part of ACRI-ST is part of the ACRI groups, which is 8 companies in 7 countries and about 180 engineers. And I want to stress that also, and researchers. Okay. It's not just engineers. I think that's important to mention that companies are interested in researchers as well. Here basically what we do is a bit anything that is related to any aspect of data from satellites. We go from all the way from the design to actually high-level products. So basically we provide services of data storage, archival, distribution, but also processing of data from level 0 to high-level products. So we also do end-to-end simulators, prototyping, etc. So anything that has to do with data for satellites, we do. So we mostly do ground segment, and a big aspect of what we do is related to the Copernicus program. So I don't know if you know about it, so I just put this slide, but the Copernicus is the European Union's program for Earth observations. It's actually the largest program of Earth observation in the world. It's even the Americans are jealous of this from Europe. It's divided in six thematics of land, ocean, etc., climate. And important aspect, so the Copernicus includes remote sensing, in situ observations, and also services like platforms. But the big aspect that people know most is basically the Sentinel missions. So these are satellites that are optimized to look at different things, some at oceans, some at land, some at vegetation, some at different things, urban growth. And basically what we do at ACRI, we work a lot, I would say the biggest part of our activities are related to this. So we take data from the Copernicus, from the Sentinel missions, we either process them, we provide them to the users, we do high-level products, etc. You will see a bit of that later. But this is our main activity. And also here, just to show, you don't need to read everything, but basically that we do everything all the way from the design to the data applications and services. So the design that could be what we call the phase A, B1 for a satellite, where it's just, thinking how the satellite should be, or the instruments, what algorithms will be needed to process the data, etc. Some kind of prototyping for simulators, all the way to getting the data from the actual satellite once it's been launched, and providing high-level products, which can be of anything, can be atmosphere, can be on land, can be on ocean, etc. So yeah, we work a lot, mostly I would say ESA, then also EUMETSAT, and of course our headquarters is in France, so also with ECNES. This is just to highlight a few programs, but I mean there are many, but I thought we should shorten this. But So as I said, we develop simulators and prototyping, and for instance, CO2M is a very interesting mission. It's actually one of the future Sentinels, so it's going to be launched all as well in 2025, and it will allow to measure CO2 at basically at a very small scale. So this is to monitor, of course, the climate, the CO pollution, and the idea is that now we have missions that can do that, but at a bigger scale. And with this one, we'll be able to pinpoint actually, for instance, industry actually generating CO2. So we can say, yeah, you guys, you know, went over the limit of your allocated CO2. So things like that. SHIME is a hyperspectral mission. And there we are doing, for instance, the end-to-end simulator. So for different missions, we do different things, okay? It depends on the contract. Also, we are an SME, so basically, when we work on these things, we are working with partnership with other large-scale integrators. So that could be Airbus, Thales, OHB, whoever, you know. So because we ourselves, as I said, we deal with data. We don't build things, okay? We don't build satellites. We don't build instruments. We just deal with the data. Also, just to say that it's not just about the design of these missions, but as I say, we can also generate high-level products. So this could be very different, but we could, for instance, we are asked to generate a vegetation index, for instance, for forests to trace their health. So we can do that, or we are asked to trace ocean salinity, which has an impact on the currents, okay? You know, your more salt, the water will go down. That has an impact on the flow of water, and it impacts the climate. So we can be asked for things like that. So it can be very, very diverse what we do. Also, for instance, yeah, before I go to that, we can also have projects, for instance, to track marine litter, for instance. So we can have models based on AI to detect marine litter, and then we have models for current, for ocean current flow, so that we can know where they are going to get close to a beach or something, so that they can be recovered. Or we can be asked also, since Sentinel data generates data continuously, okay, so they are constantly monitoring the Earth. Maybe if there is a disaster, a dam breaks or something like that, we can be asked to produce data quickly to help aid relief activities on the ground. Then, of course, an important aspect is that the Copernicus data generates, okay, we don't only do Copernicus, but I'm just focusing on those, but they generate a lot of data, okay? This is much larger than what you are used to in astrophysics. So, for example, when they say James Webb is going to generate a lot of data, and they're talking about 0.5 petabytes or so, or then they say Euclid 10 petabytes, that's for Earth observation is really peanuts at this level. So in a way, many of the challenges that actually, let's say, astronomy and planetary science are going to face, in a way, being solved in Earth observations. So there is a whole big team in ACRI-ST of data who are dealing with all that has to do with the infrastructure because it's not just gathering the data, but you need to process it in time. You need to make it available to the users easily. So that's it's a whole story. You cannot just, let's say, you have a system that deals with 1 petabyte. You cannot just scale it to deal with 100, for instance. It's completely different structures. And then also to say, we also, since 5-6 years ago, we started also applying our expertise to astrophysics and planetary science. That's in fact why I was hired to expand this area. So because there are a lot of synergies, as you can imagine, we're observing the Earth, planetary science are observing other planets. We also deal with radiative transfer models. We do a lot of things that you guys do, we do. So there is a lot of synergy. And also there is a lot of synergy in all that is data processing on ground segments. So here I'm highlighting a couple of projects that we are working in the field of space science. So we have Explore, which we will talk actually about tomorrow in the machine learning session. And there we are, okay, this is the one on the top left, but basically there we are basically providing applications to exploit Gaia data and also for lunar exploration. And we also provide a platform which is called Explore platform, which is also like a kind of geo browser where you can actually look at the moon, like what you do with Google Maps, and see which data has been taken in certain regions, visualize it, analyze it, etc. Then we are also part of Europlanet, of the Europlanet research infrastructure, the 2024, where we are working in the machine learning work package, so developing tools for the exploitation of planetary science data by you guys, and also with giving the platform. So then another, well, it's not a project in class, but it's a common laboratory, but with an university, with the Institut Astrophysique Spatiale in Paris, in Université Paris-Saclay, where we are developing data fusion tools for the James Webb Space Telescope, for the MIRI instruments, as actually, and the ways to also apply it for Sentinel-2 and Sentinel-3 data, but okay, here I'm not focusing on that. And another example, so for instance, the top two, the Explore Europlanet, are European. In-class is a national French ANR LabCom, it's called. And SciApps, which is from ESA, which we are creating what is called a science application store for the ESA Data Labs. So ESA Data Labs, the idea is to basically before the challenge was how to bring the data quickly to the users. Now, when the data has become too big to manage, the goal is completely different. Is how we can bring the users close to the data and to the tools. So the ESA Data Lab is going to be doing that. So the idea is that you can put your applications into the ESA Data Labs using resources from the ESA, and you have a direct connection to the data from ESA. So it's all faster. So for there, we are doing that module that is the Science Application Store, which is basically think of Google Play or Apple Store, but for scientific applications. So where developers can put their applications that can be used by other users. And I think that's about it. I mean, just to mention, for instance, in our company now, we started also recently, it's the only part of hardware now we do is started to basically provide services of ground segment for the new space, for the CubeSats. So we are having now a few antennas to receive data from CubeSats in a place in Grasse, in south of France. And also we actually have the two telescopes. They are brand new. They should be operational like in a month. One is 30 centimeters to do activities that can be outreach or a bit of science and things like that. So it's just to highlight that it's not just all a business and and money. And that's all I have, okay, for ACRI-ST. Then I don't know what else.
This was perfect, thanks. Thanks very much. So just as some quick background information, I think one thing we'd quite be interested in knowing is what your career path looked like to end up at ACRI-ST, because it seems like there is similarity with some of the work we do in academia over there. What made you go this way, and how did you end up in this direction?
Yeah. I guess my path will be maybe similar to many of people, but I have a background in astrophysics. So I did a PhD, it's both technical and scientific, but I did my PhD in the Netherlands, in ESROM, so the Space Research Organization of the Netherlands. Linked to the institute, which was Captain Astronomical Institute, and I basically followed my career in infrared satellites. So there I was working with ISO data, spectroscopy. Then after my PhD, then I moved to the US because then the next infrared satellite was the Spitzer Space Telescope, and I went to Cornell University because one of the instruments was designed and done there. And there I was actually research assistant with what is called open-end contract. So it's indefinite, okay? And I stayed there many years, 7 years, but then eventually I met my future wife and she was working in France. So then I eventually moved from the US and I went to France, but then in France, indeed, I did not have a position, right? So I got a Marie Curie Fellow, and then I tried to apply for permanent positions in academia. in France, and I remember it was the CNRS. At that time, they were giving 2 positions for what I was applying. I was third, so I was very close. I didn't get it. So then I moved to the UK, with another fellowship, with the idea that basically this will become a permanent post, but it didn't. So then eventually I said, well, it's time to change. And I moved to industry. That was my basically motivational reason. And basically, I think it's also a combination in a way of luck or also looking around. But then, I found ACRI-ST, which, as you see, there are many similarities with basically astrophysics, I would say. I mean, you're doing Earth observations, and then also they wanted to expand in astrophysics. So basically, it was a good match for them. And that's it. That's how I end up there.
Okay, thanks. I have a lot of other questions too, but I'd like to maybe get on to Marcell as well. Does anyone have any quick questions in person or online for Jeronimo now? And before we move on to Marcell, and then we can go into a wider discussion. Yeah.
Thanks for the talk. It was really nice. I think it would be interesting to hear from you. What kind of advices would you give to master students or PhD students that are not sure what are the right steps to take if we want to go to industry? Because, yeah, I really have no idea what I should do, I would do if I have the right skill set to move to industry. So give any advices?
So I would definitely, I'm sure you have the skills to go to industry, right? The same skills that you have to become a successful scientist are the skills they want also for you in industry, right? So I don't think that's I think what can help sometimes, and this is something, I mentioned we're in the machine learning project in Europlanet. We're also in the industry team trying to foster collaborations between industry and academia. And I think that's something that could help a lot is, for instance, when you guys do PhDs or masters or whatever, to do one with a company, right? Or that it has an industry element of it, right? Even if it is short or whatever, just to see whether you like it or not. And also, I have to say, there are many, many different options. It's like in academia, you have many institutes, many different people, so you might like, so you might not. You might fit in better in ones, but not in others. So it's very varied. But in terms of skills, I'm pretty sure as scientists, you have skills to go to industry. There's no question about that. That's for sure.
I can just add maybe one comment. Come to the industry session in the afternoon.
Yeah.
We've got a bunch of companies coming over.
Mm-hmm.
We've got, most of them are Central Europe. So they are companies from the Czech Republic, Slovakia, and Hungary. Now, if you don't picture yourself working in one of these countries, then maybe don't. But the point is that it will give you a bit of an overview of the different companies. And some of the questions we'll ask them in the discussion session are specifically linked as to what are they looking for in collaborations with academia. The thing we've realized fundamentally is that between academia and industry, there's very often a gap because hopping from one to the other is not straightforward. It's not a very permeable membrane. It's something where it feels like you either do one or the other, and jumping back and forth is very difficult. In some sectors, it's easier. Pharmaceuticals, for instance, it's quite obvious that doing research in a company or research in a university makes sense. Planetary science, a bit less obvious. But the reality is that, as with Jeronimo's example, and I'll talk about what we're doing afterwards as well, there's all kinds of non-standard career paths out there. And the reality is that you don't hear about it when you grow up as an academic, but most people don't stay in academia who go through a master's or a PhD. They all end up having a life. They all end up working somewhere. So the reality is it does happen. You don't only have academia, but it's not obvious because the people who teach you are the ones who stayed in academia. So
also to add, it might be easier to get your PhD first. You jump into industry. You want that because once you're in industry, it might be more difficult to then get your PhD. But then there are many, I mentioned it, but for instance, we now in my department, we are co-funding 4 PhD students, for instance. It's a bit high for us. Actually, we usually have a bit less just in this department. But basically, there are PhDs with companies, right? So you basically get both, right? You get exposed to both academia and also industry, which can be very helpful, right, for making up your mind.
Okay, thanks. If there's any other questions, just write them down or hold on to them for a sec, because I think it's probably best we introduce Marcell at this point. So Marcell Tessenyi is from Blue Sky Space in the UK. I just invite you to give a quick introduction to yourself, maybe a little bit about your career path, you and what Blue Sky Space are doing.
Yeah, absolutely. So, hi everyone. I'm Marcell. I did a PhD in astrophysics in London at UCL. I worked on the characterization of exoplanet atmospheres. We worked on a number of mission concepts to build a satellite that will be doing infrared characterization of exoplanet atmospheres. During my PhD, we actually focused on a satellite called ECHO, which was a candidate for the third round of Cosmic Vision with ESA. In the end, it was not selected, but then later another iteration of that called Ariel now got selected and is going to be launched hopefully in 2029 or whatever it is. I started that in 2011 with my PhD supervisor at the time, and I was a bit nervous that it takes about 20 years typically for satellites for research. Oh, surprise, surprise, it will be almost 20 years for that satellite to launch. And that's really the reason why we started Blue Sky Space. As I finished my PhD, we got the news as well within a few months after that. I just started a postdoc that the satellite that we were working on was not selected. And in fact, a competing exoplanet mission was selected, Plato. And so it was like, well, if there's been an exoplanet mission in this round, there's no way that in the next round of mission selections from ESA will be another exoplanet mission. So it will be at least 8 years before there will be another candidate opportunity. Turns out that didn't happen. Plato was selected and Ariel was selected, but we didn't know that back then. So as a consequence, what we decided to do is actually to try to see if we could do an alternative way of delivering scientific satellites. And that's what really led us to do Blue Sky Space. And I'll talk about Blue Sky Space in a second. But during my PhD, while I started with doing simulations of atmospheres and using line lists to predict the composition of or the impact of spectra of the various molecular components in an atmosphere, etc. I also got involved more and more in the project management side of the satellite. I was working with one of the partners in the mission, an organization called ACRI-ST, which is in the United Kingdom. It's a sort of a government-owned research lab that does a lot of components and instrumentation for satellites. So through that activity, I got exposed throughout the PhD, I got exposed to the technical side of things and more to the management of it. And I realized I really enjoyed that. And so I carried on doing a bit more work in that, helping prepare the documentation for the European Space Agency, etc. So that gave me a bit of visibility and understanding. And I was very fortunate because my PhD supervisor at the time saw that I was also enjoying that. So she actually advised that I signed up for a 1-week course on spacecraft engineering, which is like a super condensed kind of executive course, which gives you a 1-week training on everything related to spacecraft engineering. Basically, you don't learn anything in detail, but it does give you a full overview of all the components of building, delivering a satellite, operating a satellite, all the implications, the risks, regulation, all those different aspects. So that was my career path. A little bit to your question as to how do you go from pure academia to something like that. In this case, it was a very clear project which led me to get that exposure. And then that was also the time where you guys might have heard of Virgin Galactic, the one that didn't go bankrupt, the one that sends tourists into space. Right? That was, I think, during just before the PhD, we got the news, or we heard about the fact that some sort of private fund from the Emirates had invested into that project to support exploration of space. And that was before SpaceX was really visible, etc. So that gave us an indication that, well, maybe there's another way of doing funding for space, because if we have to wait for the space agency, it's going to take forever. And so that got us to start Blue Sky Space. And the idea was that hopefully we'll find a rich philanthropist who wants to throw lots of money at science, and then we'll build a great satellite. Surprise, surprise, that doesn't work. However, the consequence of that was that we did spend a lot of time studying the technical capabilities of an alternative smaller satellite using off-the-shelf components. Instead of going big, instead of going very large billion-dollar class satellites, what could we do with a modest few tens of million dollars, euros type of satellite, and what kind of science could we achieve with that? So we started doing that. We set up a company to act as a legal entity for this project if one day that works. And so that's how we got started. In the meantime, what we've realized is that there's all these ground networks of telescope like Sloan Digital Sky Survey, ACRI-ST, and others, where there's a model where, and also ground telescopes like Keck, where universities can buy nights of telescope time, or universities can buy a membership and to be part of a survey program of one of these ground telescopes. So as we saw that happening, we started to look at, could we merge these two models? As in, could we do a off-the-shelf local satellite and merge this with a sort of a membership model, or sell the telescope time on the satellite to universities? We had no idea if it would work. We didn't know if it's going to be a success, but we started doing this. And actually, it turns out that it's a lot of work, but after quite a few years of effort, we realized that there is a way of doing this. We've been able to progress the technical design with the satellites. We started working with large manufacturers, Airbus, ABB, and we now have a smaller satellite that's been funded by the European Commission called MOVE that we've been working on. Nigel might have mentioned it in one or two sessions. And so we now have a pipeline of 2 different satellites that we're working on, which are being delivered, in a sense, quote unquote, privately. And the purpose is that, or the approach we're taking is that we fund the satellites up front. We find a way of financing these satellites. Once the satellite is in orbit, people can then buy a membership or get access to the data sets. If everything goes well, we recover the cost of the satellite, and then we didn't lose any money. Even better, we managed to actually extend the life of the satellite. The satellite operates super well. There's lots of people who want the data, and now we start generating a surplus. If we do generate a surplus, we then reinvest that to build a 3rd satellite, a 4th satellite, and then we can grow a sort of a fleet of satellites. And the reason why we're doing this as a private approach, there's 2 aspects to this. The first one is instead of the big space agencies, we don't have the same requirements in terms of difficulties and challenges in competition. So we can go to the best manufacturers and say, well, what's your price? And then they say, well, this is our price. And we say, what are your performances? We do this, but this is a bit rubbish. Then we can take a view as to whether that's the part of the component that's not very good. Can we accept it? Can we work around it? Can we use software to mitigate against some of those components? So that gives us a chance to take a more flexible approach, whereas the space agency will say, you need to meet 1 part in 10,000 over 10 hours, and this is what the spacecraft has to be able to do. Then you go to the manufacturers, and they can meet, let's say, I don't know, 200 in 10,000. It's like, oh, well, that's not good enough. You have to go back and redesign your detectors, redesign your systems, whatever. And that costs a ton of money and takes years. And what we're doing is we're accepting a trade-off in terms of, well, if this is the best performance we can get out of it, but it actually means that we can deliver this in a few years, then we're going to take that choice, as long as the science is still doable. So that's one element. And then the other one is that by taking a more private approach, we are not necessarily just relying on grant funding. It allows us to tap into getting individual universities, private universities to participate. And it also gives us a chance to get the backing of individuals who really care about the evolution of the space sector, which has now become a lot more exciting from a commercial perspective because of the whole new space evolution. So when we started this, new space was basically Virgin Orbit or Galactic plus SpaceX had started, and that was more or less what new space meant, plus a whole bunch of CubeSats, but that were still in the early stages of having launched maybe 1 or 2 CubeSats. Now it's gotten to a point where it's clearly overtaking almost everything else from traditional space. So I think that means that this is quite a ripe market. It means that there's a lot of opportunities for careers. There's all kinds of jobs left, right, and center, not just technical, not just scientific, but also marketing, sales, communications, all kinds of different aspects that were not necessarily there before, which means that it's also a more exciting environment because you're not just meeting people who are the same education and training as you, but you meet people from all kinds of walks of life. So yeah, so with Blue Sky Space, that's what we're working on at the moment, and if things work out very well, we'll have a fleet of satellites that will be delivering data sets to everyone. And maybe a final nice touch on this, we did a video with the members who've decided to join in and participate in the satellites that we're building. And we thought that they would be talking about the data as the main reason for participation. Turns out that most of them talk about the fact that this is a new way of doing global collaboration where it's not political anymore. It's just, whether you're in Taiwan, whether you're in South America, it doesn't matter where you are, you get the same access to the data, the same status. It's not that Professor X is PI and so everyone else is just following. It's a chance for everyone to be having access to the data sets in a very fair way all around the world. And that's something that we see is also having a big change in the way people think about these satellites. That's what really we're the most excited about.
So I again jotted down a lot of questions, but I'd just like to throw it out to the room and anyone online. Does anyone have a few quick questions for Marcell?
Yeah, I'm Nadia from Greece. It's very interesting that you both have successful stories to tell us, and maybe we may find some elements to reproduce into our cases, so to carve our future. The course you have joined, the very focused one, what was that? And if it was funded by you, by your institute, how did you pay to get? Because if we would like to have access to information and very technical and very focused, does that cost a lot? Doesn't
It's a great question. I would need to look up all of those questions because it's been 10 years now. I think it was the University of Southampton, But it's a traveling course because I think it was started by people from ESA, and then it became sort of a course that goes around and happens in multiple places. I think it was called something like Introductions to Spacecraft Systems Engineering, something along that. And it was not cheap, but it wasn't crazy expensive either. It was just a 1-week course. And I think the way we got it funded was that as part of the PhD program in the UK, we were funded by funding authority called STFC. And I think there was a pot of money you could apply for professional training. And I think it was through that we managed to get it funding, but honestly, I don't remember now.
Okay, thanks.
But if I had to guess, it was probably in the order of €1,000 ballpark. So it felt like a lot of money at the time, but it was something that there was a grant application for in the context of.
Any other questions in the room or online?
Yeah, thank you for the talks. And my question is probably for both of you. So maybe what are the similarities or the difference in maybe like day-to-day life, like in industry compared to academia?
Okay, I guess there are pros, cons, depending on how you see it. I think in a way, when you're doing research, you have, let's say, flexibility in terms of the research you are doing and also on how you manage your time. In industry, it's more structure, okay? So basically, you have certain project, you have to do exactly this, and you have to do that, okay? So in that sense, like, you could see it as less flexibility in some way, but on the other hand, it's more structure, it's better organized, I think, definitely. I think also in terms, this is personal, of course, but in terms of work balance, I think it works better. It's something I learned when I said at the beginning, I would send emails late, and then no one will reply, right? And they wait, they respect your hours. There is no working in weekends or Christmas. I mean, you can have, of course, sometimes a burst of activity or something, but they respect very much that. I think that was not something I found in academia. That's something you have to constantly work, I think. There's no breaks. So that sense is better. In companies, I also think you have also hierarchy to respect. You have the managers, you have people above you, so can tell you what you should do. I mean, you might have some liberty, right? In our case, also I should mention we are more, our group, we are like 4 astronomers actually. So we have some freedom, especially a colleague of mine, to do projects, to do any project that, because they want to expand in planetary science and astrophysics. So we actually do have some degree of freedom to look for projects, to do stuff that is on our own. But then, of course, we have other projects where we have to respect, right, the deliveries, meet all the deadlines, and that's. You cannot miss them. If you have a problem, you have to have a risk assessment. So. But on the other hand, I have to say you learn a lot of things also, right? I think you learn them how to be more organized, how to think in advance your projects. When you write your projects, even if you have expertise writing proposals in a company, it's you have to be more realistic. I felt in academia sometimes to get a proposal, you have to look at the big picture always, and you say, wow, we're gonna find life in Mars. Well, if you have that in a company, you better find it, right? You have to show it, right? So anyway, but anyway, in the day-to-day life, so, okay, I do mostly more, I would say, project management, but so it's a bit what you would do if you were leading a group in astrophysics. I think it's a bit the same. It's just that you really need to be more structured and really respect all the deadlines and milestones, and you have to be more precise, I would say. So day to day, I think it's fine, but you go home at 5 usually. So that's maybe.
I agree with everything Jeronimo mentioned. I think maybe just another comment on this is that in general, I think there's 2 things that come with this, which is that it's more of a team effort. Mm-hmm. So for instance, let's say you write a proposal. Well, you will not be responsible for everything in the proposal. You'll be responsible for part of a proposal, and you know that somebody else will be responsible for another, and you will actually talk to each other. And when their proposal writing time is there, everyone is focused on it at the same time. So it's a team effort that's also very focused. It tends to be more limited. So you don't do 12 things in parallel. You just do a few things, right? And if you're writing a proposal, nobody's expecting you to go to join the departmental seminar. You know, the fact is that it's focused, you know what you're supposed to do. So your stress level in a way is lower. My experience in academia has been that you've got 15 projects happening in parallel, permanent applications for grant funding all the time. And when it's finally the weekend and you start to relax, then you feel guilty because you should be writing your paper. And that's something that I found was quite oppressive with time, but that was the way it was. So I didn't really question it. But when you realize is that in the industrial world, people have a sort of, I think, a healthier life where they leave the office and they're like, I'm done, I'm not working. And that's quite refreshing. So it doesn't mean that there's less that's getting done, but it's more limited and focused. And very often you'll have an idea of something you'd like to do. And then you talk about it with a few colleagues, and the conclusion is, let's not worry about this. So for instance, in the industry session this afternoon, we invited a bunch of companies to join. And I spoke with one of the managers of one of the companies that we thought would be interested in coming. And he asked a few questions about the session, and I said, yeah, okay, but blah, blah. And I thought that they would say yes straight away. And I said, no, you know what, we've got lots going on. No, thanks for the opportunity, we'll pass. And that's something that in academia, typically the answer would be like, oh yeah, sure, I'll come. And that's an example, let's say, where you see that an organization, they could have all kinds of upsides for participating, but they've already got so much to do that they're just being realistic. Now, of course, in academia, many people are also like that, but in general, as a trend, you really can tell the difference in that size. But the trade-off of this is, as Jeronimo mentioned, is that you get a little bit less independence, in the sense that you want to go around and do 12 different projects. At some point, your line manager is going to say like, well, look, that's all fine, but we've got deliverables on this date, and this date. If you go around doing all these conferences, you're never going to deliver any of these. And so you have to make some sacrifices. So that's the trade-off.
Yeah, I think what you say also, indeed, is a team effort. And you need, in academia, maybe you are looking out for your research, your projects, here you are looking more for the goodness of the company in a way, right? So everything goes well. So that's a bit of a shift, I guess.
Yeah, your name is not a brand anymore as much, right? It's not like everything that you do is because you want to be first author or you want to have citations. In the case of a company, nobody cares about that.
Nobody cares.
So if a company puts in a technical note or a publication, it will be authored by whoever. Nobody in the company cares who's the fourth author. Nobody cares, as long as the company name is there, people are relaxed.
You could do a proposal for a project, and maybe you're leading it, but someone else, if you get it, someone else actually will do the project, not you, or the other way around, right? Someone else got a proposal and say, hey, we want you on it, right? So it's very, that I definitely agree.
Okay, thanks. I think next we want to go to a question online. So I think, Scott, you can unmute yourself if you want to ask your question.
My question was, it's kind of broad, was how would you describe the direction, the growth of the Earth observation industry globally, and how quickly is it growing? Are there any differences regionally between the US, Europe, East Asia, etc.?
So the question is about the growth of the Earth observation. Yeah. So, okay, with now there's a lot of emphasis in the climate, right? And so all that this observation is definitely is growing. You can tell the company we work for is growing, actually, started significantly, and we are an SME. So there are many more satellites now being launched. There are many more opportunities. I would say in the Copernicus program, one thing is that it's all the data is public. Okay, so that means that it's actually Europe who is putting the money, but this data could be used by anyone. Could be used by US, could be used by China, whoever. Right? It's public. That's the Commission makes important this an important aspect. So there's been a lot of discussion, of course, of whether we're giving data in a way for free, no? But the idea is to that all working together we can make this a better world and things like that. So why not? But definitely the US also have a very strong Earth observation program, of course. Also, India is also investing a lot in their space program, so is China. So it's definitely a growing sector. I should also say there is an aspect, monetary aspect of it, is that, for instance, for every euro spent on Copernicus program, there is a return, I think it's estimated to about 1.6 or so, 1.7 euros. So it's actually profitable. Okay? So it's not just, okay, it's for climate, whatever, but it's actually generating income. Okay, so this is because these observations can help you in agriculture, you know, to be more efficient in many different aspects. So it generates also jobs. Of course, so we have companies, we're giving jobs to people, so it's profitable. And I think there is also, perhaps, maybe that's not related to the question, but just to mention, Earth observations, there is a difference with astrophysics or planetary science. It's important is that in many cases in astrophysics or planetary science, they fund the satellite, the instruments, but then the actual exploitation of the data is figure yourselves out, right? In Earth observations, the missions in a way cost less money, I would say, and there is much more money for the actual exploitation of the data. Okay, so there is a lot of more of opportunities, and actually that's how we are working. That's the model we are working, right? We are basically getting a lot of proposal grants to exploit data from different missions. But in terms of growth, yeah, it is definitely growing. Yeah.
Okay, thanks. And this is actually an interesting point. I'll ask something first and then I'll go back to that. I don't know if you wouldn't mind talking about how the very scientific parts of your work have to be done or not in collaboration with academia. So, for example, the scientific scoping of MOVE, for example, is this done in partnership with academics since they'll be the end users of this? Are they within Blue Sky Space? Do you use them as consultants? Do you just look at white papers? And then with your models, do you have to use academics who have built these models? Do you bring them in-house and employ them at ACRI-ST? I don't know if you wouldn't mind going first, Marcell, and maybe Runway.
Yeah, of course, absolutely. I mean, we are perhaps a little bit atypical as a company in the space sector in the sense that we're very much focused on space science and astrophysics, and there's not many companies like us at the moment. So the reality is that I don't know how applicable this is to other cases, although as it happens, we also have a case with ACRI-ST with another scientist working in a domain which is also working with science. But yes, absolutely. I mean, given that the community we're serving is the scientific community, of course we have to talk with them. There's a number of ways we're doing this. So number one, we recruit people in-house. We've got project scientists. We've got scientists coming in, doing 6 months internships with us. We do all kinds of different approaches to work with the scientific community in-house because we need to develop our own capabilities in-house. When we started with Twinkle and then with MOVE, these are two science cases that we understand fairly well in-house. With the founding team plus a number of people around us, we know really what we're supposed to be doing from a core perspective. But actually, it's by talking to the community that we've heard about all kinds of other applications and use cases for the satellites that we haven't thought of because it's not our background. And that means regular interactions with the scientific community. And that is an interesting point because how do you reach out to the scientific community for input or for interest? It's not something that they're used to. They're not used to having a company turning up and saying like, well, would you be interested in this or this or this? That's not something that's a standard way of doing things. You know, usually you go to a conference and then scientist X will say, well, I'm leading this mission proposal with ESA or with NASA or whatever. If you're interested, come and talk to me at a coffee break. That's really how it typically works. So of course we go to conferences, we try to meet as many scientists as possible. We send out newsletters and so on and so forth. But it still is something that's a non-standard way of communicating with the scientific community. But what we're seeing is that each year the younger generations which are into academia are more and more, I would say, easier, let's say, to approach and to communicate about these things, as opposed to people who've been in the community for maybe 30 years and so on, because they're very much used to one way of doing things. And so it's a bit harder to communicate with them sometimes. Again, it's case by case, but as a general trend, I think that's what I've noticed. So yes, we definitely work with the community. We definitely give opportunities. If we meet someone brilliant, we offer them a job. I mean, that's something that we do on a regular basis.
Likewise, I mean, all the projects we mentioned before, they are all done in partnerships, and most of them includes academic institutions. So this is a very important part. So as you say, Marcell say, we need an expert on something. We contact, it can be a company, can be a university. That's relevant in a way, right? We get them. So we will be talking about the Explore project also tomorrow. And okay, it's led by a colleague of mine, but Nick. But this is a project with partners from Europlanet also. Okay, so also we have, let's say, sometimes with some universities agreements in the sense that basically it's like kind of contract where it means that if we require them for some projects, we can put their names on it. If they require us for something else, they can put our names on it. There's some kind of, and we have that also with a few academics, actually, institutions. So, okay, not a lot, but very defined because, there's a big expertise on some area maybe. For instance, atmospheric modeling that we're interested, and we want to tap into that. So there are contracts that we can use each other.
Just maybe another comment I'd add, which is that actually getting consultancy from university can be quite complicated, not because of the research or the academic, but because of the overheads and bureaucracy of the universities. So it's sometimes easier for us to actually get an intern or to recruit someone directly than to actually ask a university to prepare a contract and so on, because that takes forever.
Okay, and I want to ask quite a broad question about whether you think, you said about respecting work-life balance, maybe in industry is something that happens more. I'd like to ask more broadly about whether you think some of the things that are applied in industry, some of the methodologies and the structure could be beneficial to academia if we maybe try to replicate them a little bit, or whether this would just spoil the magical machine that is academia. And in a related way, I work, for example, we're developing an instrument at MSSL in the UK, an EUV spectrometer. And something that we experienced when we built the last spectrometer, I wasn't there for this, but the funding was great up until the launch, and then the funding completely disappeared. So the website is absolutely disgusting and horrible, and it's out of date and it's rubbish. So is there anything you think that could be done differently or better to stop us building great instruments and not exploiting them properly? But the first question about bringing stuff from industry over to academia.
To me, I think, having been in academia then in industry, I remember after several years in industry, I did one of this common laboratory called in class that we did with this Institute of Astrophysics Spatial in EIS. When I did it, I remember I did all the, work packages, all this kind of stuff, and it was really detailed, but that was now based on my expertise from industry. The people from EIS, we had worked in before, right? They were very impressed. They said it was, oh, wow, this is very, very well structured, how the work packages are structured, how all the tasks are, distributed, all the links, all the stuff. And I thought that's something, in a way, I guess we learn in industry to do better, maybe than in academia in terms, because you really need to be very realistic. So I think that was something again, I think the best is you have open-minded scientists. You try to take the best of each world, right? Scientists are also very good at other things. They're very good at abstract thinking, right? And they like that in companies also, right? So you try to take the best of each. But I would say, yeah, organization, project management, these are definitely skills I have improved while being in industry that I think could be useful for academia. I mean, not saying they don't have that, of course, but it's a bit different and it's more streamlined and more precise, I would say.
I mean, in that spirit, I think the fact that it's difficult to go into industry and back into academia and back into industry and so on, that means that we're missing out on these opportunities to share knowledge. I mean, one of the things that's for sure happening once you go down in industry is that you get locked into a certain limited number of topics and projects in which you work. So you might become very good at this, but what you lose is this sort of broad knowledge of what's happening across research. And so, for instance, for us, that's why it's very important that some of the team members are full-time academics, because they bring us all kinds of new ideas and developments that we didn't know are happening, because we're just so focused on delivering a certain number of things, which we're delivering well, which we're happy with. But that means that you can't be simultaneously open to everything and focused on one thing. You have to choose. And so once you become an industry person, you kind of lose that broad vision, and that's not necessarily a problem, because you can then be invited to join a few seminars at the university, and then suddenly you start to feel up to speed again. Go to a conference, you're up to speed as well. But it's not the same level of broad knowledge. So I think from that perspective, I think if academia were to become too much like industry, you would lose that magical machine, as you said. But definitely on the work-life balance, on managing the sort of from a realistic perspective, what's achievable in a certain time frame, because you're not by yourself. You definitely need to sync up with other people. That means that you need to send, heads up to people 2 weeks before the deadline to say, listen, I'm going to need something from you. Oh, I'm on holidays. Oops. Those things need to be sorted out. You need to plan for all of those components. And industry, you will not get away with last minute pulling things together or stuff like that. It has to be planned. And that really, I think, is something that I've seen in academia. Some people are very good at that. But as a general trend, I've seen more the opposite of that. And I think that's something that could be, would remove some stress, let's say.
I think also in industry, people have strong expertise in different areas. And I think in academia, you were very good at, I think, experts on many different things, right? You know how to do science, you know how to write proposals, write articles. I mean, you have you have IT skills, outreach, teaching. There are many stuff, right? And I would say in industry, maybe you might think you're good at programming, but of course, then in industry, you might have actually a developer who is just, that's his job, and he will be better than you, of course. It doesn't mean that they're not interested in your skills for that, because they know you can learn it, so they don't care about that. But I would say that, yeah, maybe where academia, we do many things very good, good for some, but in industry, maybe you're more focused, you're extremely good people at one or two specific things, and than doing absolutely everything.
In terms of stress handling and well-being, and coping with deadlines and all this kind of stuff, and personal life, how is that compared to industry vs academia?
I mean, as I say, I think it is better, but that's of course a personal thing. I think you have to see yourself, I would say, but I think the work balance is definitely better. That's what I think. That's not to say you don't have, of course, sometimes you have issues, right, in the company too. Something didn't work in a project, and you need to deliver. So yeah, of course, there are stressful moments, right? And in this case, it's not about, I don't know, I might get a scoop in a paper or something like that, but actually then you have a client, there is money involved. So there is, there is a stress. I wouldn't say it's all super nice, all the time, but there will be bursts of some stress, or sometimes it happens when you have also deadlines that are all together. That happens in industry sometimes, but I do think they try to respect that better. For instance, so they see that we did a proposal, for instance, time is very stressful. So if, for instance, in my case, they say, okay, you did 1, 2, 3, 2 together, it's too many together, then they will give you a break, they'll say, okay, take a break, or they give you some lower task, or have a week, I don't know, whatever. So, and that they respect that. I was very impressed the first time when I joined. I remember we're talking with a client, and they say, at that time, our company had to take 2 mandatory weeks of holiday in August. Now it's more flexible. Before there were 2 weeks that had to be taken there. And I remember when I say, oh, we have like to have this here, and my line manager say, no, we're on holidays, so you have to move it, Now, that doesn't mean, of course, it depends if it is critical, you try to accommodate the client, of course, and then, but then if you don't take your holidays there, they will give you holidays later, right? So in that case, I think it's more respected. And as I say, I was making the mistake of sometimes sending emails to people very late or something, and you could see that, no, that's not okay, let's say, right? You should send them during work hours mostly. Again, of course it happens, okay? It does happen. Sometimes you have these deadlines, but in that case, I think it's better respected.
I agree with what Jeronimo said. I agree as well. There are stressful times, your deadlines and so on. But what will happen is that because it's a team effort, you will have actually a rational conversation about it with a number of people. And there will be a reflection inside the team that will be saying, well, look, this is really a priority, this is maybe less of a priority, actually, let's cancel this for now, let's postpone this, let's focus on this because this is the most important. Or if sometimes needed, let's withdraw from putting in a proposal, for instance, because it's just too much stress and we need to deliver something else as well. So the fact that it's a conversation, it's not your own name, it's not your own brand, it's suddenly a team problem. That means that I find it healthier in terms of interaction, but that's my preference. Some people, of course, will.
I should mention we have, for instance, RETEX, so return of experience. So when we do a proposal, even if we get it or not, we have a RETEX, and also about a project. If we have a project, at the end of the project, we also have a RETEX. And then you see things that work, things that didn't work, and then they try to mitigate, right? They say, oh, you know, I was stressed because I needed this budget and I couldn't get it, people were not available. Then, okay, they'll take note, they'll try to see that next time, you know, it doesn't happen, things like that. So there is a process also in place to see what works well, what doesn't, because obviously sometimes there are issues. Sometimes it goes well. But...
Okay, thanks. Are there any other questions in the room or online?
Yeah, because I think that question or a similar question was asked yesterday in another session. Depending on like level of education or positions that you have already had, because I mean, I'm a master's student myself, and there's also a lot of PhD students. So what level might be an advantage or disadvantage to start in industry? Because I think the question yesterday was like, is it harder if you have a PhD or like a further position, maybe because people think you might be too specialized already, or does this kind of happen at all? Or yeah.
So from our perspective, not really, because it really depends case by case. So for instance, if we're looking for someone fairly junior to help us do some of the tasks that maybe are less complex, where we don't necessarily look for leadership, but we look for someone who can grow into the role and then become a team member who can then help us implement all kinds of things in-house, then we'll be looking for someone perhaps with lower levels of experience. Whereas if we're looking for an expert in this particular topic, then yeah, we hope that that person has had a PhD and that person even had a few years of a postdoc, so that it's very pertinent, so that they come and they tell us what we're supposed to be doing. So it depends for the role. There's different types of levels for different activities. And the reality, the bottom line in all of the recruitments we've ever done is that if the person we're talking to is brilliant one way or another, then we will find a way of accommodating that person, even if it doesn't fit the initial job description. We are open-minded. Right?
Yeah, fully agree. So for instance, when I join in, okay, together with very close to a colleague of mine who, let's say, we both have more expertise, more years in academia, but on that sense, they wanted to expand, you know, explore this new area of astrophysics, planetary science. So they wanted someone maybe with more networking capabilities, right? So we were good for their role, right? So now we're kind of leading this expansion of this department, but then now we have someone which is more, let's say, less experienced, but kind of you could see he can be project manager, but then we have someone who is more junior, right, to help on other things. So again, it really depends on the role. And maybe important to mention is that they do not care industry, but at all. They don't see like you are leaving academia for industry. They don't feel, because I think that some people feel like it's a failure, you know, people want to be in academia and they're switching to industry because they couldn't get a job in academia. That really they don't care at all. But
yeah,
at all.
There's zero emotions.
Yes,
Zero.
it's completely irrelevant for them. It's
Thank you.
Yeah, thanks.
I mean, sorry.
Sorry.
Just final comment on this. I mean, I remember because many of my friends went into careers in industry straight after university, right? Whether they went into accounting, law, finance, whatever. For those companies who ended up in graduate jobs, something I've heard very often from them is that, at least in the UK, actually more education is almost a negative, because those companies want to recruit, you know, the top 100 graduate recruiter companies and so on. They want to recruit someone who's very junior, who's going to follow all of their training program and is going to be molded into being a compatible person with the organization. So for them, actually, having not a PhD and a postdoc was seen as a negative, because that meant that you already were fixed in certain ways of doing things. I completely disagree with that view of the world, but that's how these companies work. So I know that that's a question that when you come to the sort of larger companies, we hear that. But in terms of, I think, SMEs and industry that's adjacent to space science. I don't think it's, on the contrary, these are very technical, specialized sectors where I think the more education you have, fundamentally, the better in principle. So I don't think the only reason why you would recruit a junior person rather than someone very senior in some cases is because if you think that's a type of activity that a person with a lot of experience would not want to do anymore, or would want, or feels that they can do it in 2 minutes and they don't want to repeat the task 5 times, that might be something that you might struggle to pitch to someone who's higher up. And also, typically, someone with more experience will cost more money, and that's also a consideration. So those are the reasons why you might hesitate between a junior and a more senior role. Otherwise, you would just recruit someone with lots of experience.
Yeah, actually, that kind of answered my question. I was going to ask if you count PhD as experience, because I was in the industry before I started my second master's, and what I observed so far is work experience matters more than your level of education, master's, school name, in most cases. So that's why I wanted to ask, do you count PhD or a postdoc as a work experience? Does it matter for you in your industry? And do you also offer PhD thesis studies for students? So that might really matter actually for the students.
Okay, if, sorry, I couldn't hear too well, but if I understand well, you're asking, okay, in terms of do we provide PhDs? PhDs, yes, definitely. We've co-found PhD students with universities. I think all companies do that. Okay, it's a very natural thing to do. In terms of your, say, yeah, PhD, postdoc stuff, I think they're more interested in your skills. Okay, it's more about skills, I would say. They will not be interested in a specific project unless it's super related to the job description. Okay, you know, if I don't know, if you are doing a relative transfer model of Mars of something, and we need someone to do that on Earth, then okay, then it is relevant. Okay. But if it is not like that, then we are more interested that maybe, yeah, that you can run relative transfer models, that you know how to, I don't know, depends on the job description, right? It can be data processing, it could be project manager. So it's more, I would say, about the skills. And sure, obviously, it helps if it is around the area, whatever projects you do are similar to the ones you need to apply. Then, as I say, I think Earth observation and planetary science, you can find a lot of similarities, I think. But so yeah, so to me, if you say, okay, I done a postdoc on this, is okay, it's more like work experience, but then I'll be more interested in what skills you learn there than the actual project you did. Or perhaps sometimes we look for people doing artificial intelligence. So, you know, at the end, we are interested maybe in the methodology you used, but whether you apply to, you know, to look for pits in Mars or so, we don't care, right? It's more, okay, we'll apply to something else. But, so it's all about, I would say, more skills and capabilities and in that.
I agree with what you said.
I'd just like to quickly ask again about this data exploitation funding. So I don't know if you wouldn't mind just giving a very short overview of the Explore project and maybe
of which one?
The Explore project.
Okay, so
there will be a talk about this later, I think.
Yeah, so tomorrow, so there will be a small talk on the Explore project, which I'll give, but actually it's a colleague of mine, also astrophysics, who is leading this project, but he could not be here. But basically in this project, it's part of the Horizon 2020 of the late space program, and I think it's actually one of the first led by, in a way, a company, but again with collaboration with the industry. And what they actually like it from this project was very well reviewed. Indeed, they like it that it was combining industry and academics. So the idea is to develop 6 what is called science data applications for the exploitation of Gaia data, visualization, and how to analyze data, and also for lunar exploration. So there'll be also a little demo later by my colleague Nick in the session, okay, for 2 of the tools online. So basically, one is basically to create, for instance, SEDs to take data from different missions and make SEDs of stars, just in a simple way. Other is basically using machine learning to look at similarities or anomalies, you will find the one way, between spectra from the Gaia data from their RVS. Okay, so you get a lot of parameters, and you want to explore similarities between stars, and this using AI. And then the lunar explorations are more for, it's like kind of a geo browser, so you can basically select a region. This will actually be shown in another session, I forgot in which one, by Giacomo Nodi. And basically you can select a region, you can see what data has been taken from this region, you can save it, take it, manipulate it. You can even look at the Mars, if there is a rover, a lunar rover or Mars rover, you can have a view of it. So it's basically for visualization analysis of data from Gaia mission and lunar missions. Those are the applications, and then on top of that, what was done is it's called Explore Platform, which is basically a place to put these applications so that people can run them. It was actually meant to be a development platform, but it turned to be quite nice, and well, we use it for that. But I mean, come to the.
So the thread I asked this question along the line of is, so I mentioned that we don't really have funding to do the proper data, all these lovely fancy data products. So we get data from our spacecraft in level 0, uncalibrated, and we have to build our own pipelines. Every individual has their own pipeline in Python, in IDL. I wrote some stuff in Fortran because it was faster, but it's not very uniform. One advantage of this is that each user can push the pipeline in the way that they want it, whereas if we have a finished data product, it's something that I guess I can't really tamper with underneath of it. I guess this means you need to work closely with quite a lot of scientists to get everything they want in one box. Is this very difficult? Is this how it works?
Yeah, definitely. We work with academics. Now, for these different applications, they are led by different groups, okay? But then there is a lot of interactions, okay? So there are, I would say, there are work packages that are, let's say, kind of vertical, okay, are separate, but then you have some that are transversal, like we are applying some artificial intelligence layer to some of the tools, or a visualization layer. And then there is a lot of interaction between the different groups. Mm-hmm. So yeah, there's definitely interaction. And in terms of funding, there are funding opportunities for exploitation of data sometimes. So you can try to look for those, I guess, and try, and maybe you can continue.
Okay.
I mean, it's these questions are very pertinent to what we're doing at Blue Sky Space, because one of the issues is that the disconnect of the historic way the satellites are being delivered for science and the lack of support for the exploitation of the data, in part, which kind of justifies also why Europlanet came around in the first place, right, to help the scientific community across Europe coordinate, figure out what the priorities are, also be aware of funding opportunities and so on. What we are doing is, because we're taking an industrial approach to this, or a commercial approach, it means that we are looking at this from how does a researcher get access to the data set in the easiest way possible with the options which are available to the scientist in the best possible way. And that means that we're looking at it as a full product end to end, from the idea all the way till the data sets arriving on the computer of the researcher, which means that the software, the delivery process, the ground segment, the hosting of the data sets, the provision of tools for analysis and so on, all of these are part of the full chain. So that means that we're really looking at it end to end. Now, as you've mentioned, that means that some scientists, let's say theoretical scientists, maybe they don't want to be playing with level 0 data. They would much rather know where the spectra are, what the error bars are, and just get on with their part of the research. But other scientists, of course, like to tinker with the data. They want to play with the pipelines and so on. And we've seen very often with previous satellites, both in Europe and in the US, where the pipelines which are developed by the community often work better than the one that has been developed in the first place by the providers of the satellites, or the centers which are managing the satellites. So what we are very careful about here is to make sure that we develop the best possible pipeline in collaboration with scientists, with consultants from the scientific community, learning from the experiences that have been acquired through the processes around Hubble, James Webb, or other satellites. But the other point as well is that we are delivering a core end-to-end solution, but there's points higher up in the chain where you can fork out and do your own stuff. So we are offering the whole range of options to the scientists, which is that some people do want to tinker with it, and we want to leave them the open, like let's say a sandbox area where they can come up with maybe a better pipeline or a pipeline that does other things. And if it's a great idea, we'll try to integrate it into the main pipeline. That's the approach we're taking, because I think that's the most flexible. And
yeah, something I forgot indeed is when we put these kind of proposals, also the Commission, for example, wants to leave we're collaborating industry and academics, but they want, of course, academics should be leading the science, okay? And we provide basically the background on the IT or platforms or services and things like that. So that's very common, okay? So basically to facilitate the science for the actual scientist.
But the big difference here is that, for instance, the user interface, we're doing this with a proper software company. Okay. We're not doing it, it's not me with what I remember from Python and some of the latest graphical interface plugins that you find online. No, we're paying a team with experts to deliver that, to do that in a way that's not only working, but is also user-friendly and clever to use. Not, for instance, like the Hubble Space Telescope Exposure Time Calculator.
Yeah, we got actually a request.
Not to name anyone.
Some people doing, scientists say, we have to do this release for these data sets for this mission, and but they had to be done in Java, and they don't do Java, so they do their best, right? And this is some part that we say, you could work within the company, which put a Java expert on it, and that's it, right? And can help on that. Yeah.
One thing I would be just slightly concerned about, and that is important, that is still passed on, is so we work with sensors that are solar sensors, so their rate of degradation is extremely high. So the sensors now are being in orbit for 10 or 15 years. We work with fitted spectral parameters, and the instrument observes in lots of different programs. But for example, when the spatial resolution is quite low, we use even just few pixels to do science on. But these pixels can be designated as hot pixels, or they might be dead. And if I was looking at the data without having put it through the pipeline myself and looking at the spectra and checking everything's fitting correctly, I wouldn't be aware of this. Do you worry, or you can tell me that it's fine, that disconnecting the end user who does lots of science with small amounts of data, could the fact that some of the data might be corrupted gets lost along the pipeline or not?
No, because there is very, very rigorous calibration and validation steps. These are followed very, very much in detail. So this is something we do is CalVal, and that's a very important thing, and it's checked by many users, and then we can get requests. And you also have people in the interfaces, right? You just don't work isolated. You have also testing groups. You have many things. So, but the CalVal aspect of it is for what we do, for us in our case, extremely relevant. It's you can always have something that is misinterpreted, but it's we put a lot of emphasis on the error of each pixel, right? Everything has to be very well documented and understood.
So from our perspective, we're insuring the satellites. That means that you need to know how your detector behaves. If there's a failure of your detectors, or if some pixels are going bad, etc., we might be able to claim insurance on that. So I can guarantee you that we are being very careful with these things. The other component is that most of the satellites which are flying today, very often the calibration processes that are being used today are completely different to the one that have been initially expected. In some of the satellites, they were probably not considered that well, etc., etc. I mean, the use case, the way Hubble is being used today, is probably not what they had in mind when it was being conceived. I don't know if anyone has ever been through the process of seeing how the nodding mode works for measuring spectra on exoplanets, but it's quite scary. The point is that we are integrating calibration straight into the processes already today on some of the satellites which we haven't even started building yet. The reality is that calibration matters tremendously, because that's a way of guaranteeing a certain level of performance throughout the lifetime of the satellite. Having said that, as mentioned earlier, we are taking the input of scientists who actually care about this. So what will happen is that you personally might really care about looking into the details of the performance of the detector, but You know, if you look at all of the papers out there in the community, most people don't go through that level of detail on the instrument. So you have to recognize that when you're looking at an academic group, you've got some people who are very, very focused on technology. Some don't care about the data at all. They just care about technology. Then you've got people who care about the data and the technology. And then progressively on the spectrum, you get to the point of people who just care about the data and couldn't care less about the technology. And our purpose here is to serve basically the whole range of people by making sure that the data quality is as easy to use for as many people as possible. And the reason for that is that it just removes some sort of barriers to entry to getting the data sets that sometimes you face with some of the other projects where you need to talk to someone who knows how to decrypt the data in the first place. But on the other hand, we also want to make sure that we work with people who care about the data quality, who care about the process of turning the raw data into usable data. Because we can learn from them as well. There will be all kinds of clever techniques and processes that in-house we might not have those capabilities. And you know, whether it is a fluke or whether it is through some developments in the community, we would miss out on that knowledge if we weren't interacting with the community.
Okay, thanks.
In Earth observation, I should mention also, you are observing is different. Specifically, you are observing the Earth constantly, right? So you have repeated, you are observing the same place all the time. Of course, illumination might be different, whatever, but it's many years, so you can always spot something that is wrong. For us, the main sometimes source of could be annoying or error is of course clouds. That's some can be opaque, some cannot, and that's. But again, you need to have a good uncertainty associated to them, and that's it.
Okay, thanks. Any other questions in person or online? Okay, then we've got about 5 minutes left. I guess I just ask if we probably draw it to a close, but if you guys could give the room and the guys online as well some advice on if they were applying to industry, what kind of things they should emphasize in applications, but if there's anything nuanced in the application process, what skills, coding, what languages are usually useful, what should people do when they're applying for jobs in the industry?
I think that's an important question because sometimes the roadblock is the CV. So in academia, you have an academic CV, and in industry, it's more like a resume, let's say. So there are similar things, but also others that are different. In the way, okay, the CV, the similarities, of course, is to show your experience and skills, so to highlight you as a candidate. That's the same thing. But then I think academia, your CVs are maybe tend to be long. Okay, in industry, you just want to go to the interview, get the interview. So you need to make sure you have the keywords, okay? Depends on the position. If it is, of course, project management, you should stress your project management skills. If it is on data processing, you should stress your data processing skill. Don't try to put everything because then it will not work. If it is too diverse, it will not work, right? If you try to put your teaching, your project management, your processing, it's trying to do too much, and you are being hired for one specific thing. You just want to get the interview. Once in the interview, you can explain things, right? So you really need to make it short. And I think, as I said maybe before, right, they don't care what you did a project on. Okay, the actual, you're looking at something in Venus or whatever, they don't care about that. It's more about the skill, you know. So don't avoid all jargon for sure. Don't put jargon, don't put, oh, I work on this mission, on this for you, you know, maybe the Herschel mission, they might not know Herschel mission, they don't care. So
or at least say, you know, a mission by the space agency.
Yes, exactly. These kind of things, but it depends a bit on what they want. But for instance, most of the time in academia, there's a lot of emphasis on papers and teaching. Those are two things they are not interested, okay? So your teaching skills are most of the time will be completely relevant, right? Unless maybe it's a position for communication or something like that, I don't know, but otherwise it's completely irrelevant. And also the number of papers you have or H-index, they don't care, okay? They want to know that you can write papers, you can write scientific stuff or project or proposals or things like that, but not about how many papers. And I think it's a very difficult step sometimes because as an academic, you put a lot of effort into it, right? So you want to transmit it, right? But at the end, that's not helpful actually for these kind of things. so you need to change a bit your mentality, I would say, in that. And one other.
I agree. I mean, just to highlight a few points, I would put selected publications. You can put between brackets how many publications you've been involved in. Fine, it just shows you've been very prolific. But just put a few selected ones that you think are somewhat relevant to what this is, or the papers you're the proudest of, so that you can show your track record. But even then, if it depends on who's reviewing your CV. If you're applying for a job where there's a lot of other people from an academic background, then they would have some sort of sympathy and sensitivity to this. If the person reviewing your job is an engineer, they'll be like, I don't know what to make out of this. Also, if you've done talks, invited talks, no one cares. Just put in, if there was a really prestigious one, if you've been invited to give a talk at the UN, okay, put that in. But if you've been invited to talk to a conference in ERIM, I can guarantee you industry what is ERIM, it doesn't really matter. So just keep it focused on skills, exactly on skills, and don't put the names of the pipelines you've used. There's so many obscure names and acronyms and so on. It makes no sense to someone who's reading that. It has to be, develop the pipeline that does this, and this using this language or these tools, or something that's universally understood. That's helpful.
So you can highlight, of course, you're good at Python and whatever. Sure, put them. These kind of things. It can happen, of course, that don't try to push it also, right? I think in the sense that I remember sometimes maybe a company wants really a Java expert, right? And maybe you have Python skills, and so maybe you're not a good fit, right? That's not a bad. It's okay, For other positions, they will want you coding Python, for instance. Okay, so don't be afraid to try, also, right? This is perfectly fine. And I would also suggest, if you are interested in industry, also to even apply to some of the jobs, even if you are not so sure, just do it just for the experience of it, to go to the interview, right? Because then maybe when there is a position you really want, you will be a bit better prepared. Okay.
Actually, if I can bounce on what you just said, a couple of points on that. So the first one is usually when there's a job spec from industry, it will say required skill and desirable skills. So that's the first thing. So if you feel that you're somewhere in between those two, definitely apply, because you'd be surprised by how many wacky applications come to industry. So, with a master's level in some form of science, or with a PhD, you're already in the top percentage of the candidates which are applying typically. The second part I would say is that if you're unsure, drop an email. You'd be surprised by how often a company will be willing to just have a chat, saying like, you might say, look, I think I've got a CV that might match, but I'm not 100% confident about this. I didn't really fully understand your role, your jobs. If it's a very busy company and they're receiving 600 applications, you will not get a response. But the odds are you might get a response from someone who says, sure, let's open a call and let's have a chat about it. And you'll be surprised by how often that is possible compared to what you might, unless you're applying for a huge company, then there's a clear process. But if it's a small company or a medium-sized enterprise, usually you'll get a chance of having an interaction.
Okay.
Networking also is important, knowing people.
Like the industry session.
Yes.
So if you come this afternoon, you'll hear more.
Okay, brilliant. Well, we're at 10:30, so I think we've got to stop there. But thanks very much to Marcell and Jeronimo. Thanks for everyone listening online for the great questions. And I'll see you in the sessions in the rest of the day. Thanks, guys.